Okay, now who remembers the area? Okay, well, now let's find out. So instead of now the cat going in a circle, imagine a windshield wiper going. So, right, so we are going to do a windshield wiper. But our windshield wiper is somehow magically going to go around all the way, right? So we are having a windshield wiper that goes all the way around. In this case, we are going to have two different things. We are going to have well, obviously it's going to do a sweep, right? But it also has to sweep the entire radius, does it not? From 0 to R. So now instead of having the surface element, we are going to have the area element. And I'll show you how that works. So our area element, pick a color.
Green. Red.
Purple.
Red. You always go purple. Let's go green.
Okay, green. So in this case, because we have the area element, it will be comprised of, think of a windshield wiper, right? You have to go from 0 to big R, and you also have to do your sweeping motion. So your area element, which I will call dA, will be a product of move from 0 to R and our sweep. So when we go from 0 to R, we can divide R into small segments. And each of these segments, I'm going to use a pink, is going to do the sweep. Yes? So we are going to pick a small delta A to choose from here. So imagine if this is, okay. Imagine if this is my circle. Oh, I can't raise my hand up. Okay, so can you imagine, can everybody see the small element A in between it's purple and black? Yeah, and it's sweeping around. Do you see the sweep? Okay, this is what we're talking about. This small area element inside here that has a small delta R or dr, and it has the sweep. So what do you think in order to go from 0 to R, that small delta should look like? And then our sweep, which was just d phi. Do we understand why we're not just calling it d phi? Why do we have to put an R in it? Can anyone explain to me why that happens? Amanda, you want to take a guess?
Because it's talking about the arc length. You take consideration how far away it is. That's what we're talking about.
Exactly. Because it has to take into account how far your dr moves, right? Because if we were like all the way in here, is it the same delta? Is it the same distance moved as if it was here? So look at path 1 and look at path 2. Are they the same distance moved? No. So you have to tell it which R you're talking about. As you go further out, your sweep changes. Got it? That's why we have the R there. Make sure we understand this because that's going to become important soon.
Yes.
Okay. So I'm going to take all of these extra lines away. So now in order to find my delta A, what do I have to do? I go back to green. So this means this is dA. My area of this tiny element that I have drawn in here is what? dr phi r d phi. That means I now have two integrations to do. 1 over dr and 1 over, good. So in order to find my entire area, I have to do 2 integrations. What's on the left-hand side? A, is that area what we're looking for? And on my right-hand side, is that true? Do you see what I did? I collected them. And what's my limit of integrations? 0 to and always. d phi is always 0 to 2 pi. What's going to be the integration for r? And what's integration over d phi? The 2's get canceled. What am I left with for area? Done. Just like magic, it just pops up. This is fascinating. We have just gone from one-dimensional sweep circumference to a two-dimensional area.